Hi, my name is Hanok and I'll be going over the Lab 1 for Physics 2211. So here's the video overview. First I'm going to go through the introduction of this lab as well as the models, the two models we created, the experiment, the coding aspect to create the computational model, as well as the discussion and conclusion. So the purpose of this lab is to observe an object that is moving with a constant velocity, and the idea of a constant velocity is also known as having no net force or change in direction. And we're going to use this to create a computational model from our results. And the three fundamental physics principles we used is Newton's first law, Newton's second law, and constant velocity. So here are the fundamental physics principles. So Newton's first law states that objects in motion can stay in motion unless acted upon by another object, so essentially saying that there's no net interactions. Additionally, Newton's second law is F equals ma, so saying the heavier an object is, the more force that will be needed to move or speed up the object. And finally, the constant velocity principle is that since there's no net force, the velocity will be zero. And here are the three main formulas we use to create the model. First, we have the average velocity formula, and to find this, we need the first two data points, or the two first entries of our tracker data, and so that's just taking position 2 minus position 1 over the change in time. And then there's position update formula, which is just using v average, and v average is essentially constant the whole time because we're using just that first interval. And finally, velocity update formula, but since there is no net force, that second half of the equation is essentially canceled out, so it's just going to be v final is equal to v initial, so a constant velocity. And here is an overview of the results we got from the tracker. So it was over about a 2.2 second time span, and you can see that this is it resembles a very linear graph, so you can tell that there was most likely a constant speed during this experiment. And here it is graphed where we can see the actual r squared value, and we can see that when I tried to use a linear model, that it was lined up with 0.99% accuracy, indicating that there was a pretty close, or almost none, external forces acting on the object. So in our experiment, there is the system and then the system plus the surrounding. So we used a spool of wire, and the surrounding of this was friction, air resistance, etc. These are all external factors. So we used the tracker app to track the position and actually get all of our data points, and then we created a computational model through GlowScript, and then we put all of our results and graphed it in Excel. So for our procedure, we first recorded our ball rolling at a constant speed, and we put the video onto tracker, and then we created the computational model in GlowScript based off the initial velocity of the object we made in tracker, and then we put this all into Excel to graph and visualize. So for our initial condition, we created a reference point using the meter stick as well as just the 0 point we created in the tracker app. And so overall the time was 2.27 seconds. Each time interval was 0.33 seconds, and based off the tracker data, we were able to find the initial position, and using that first two data points, we can find the initial velocity, which is just the data point from 2 minus 1, so the change in distance and over change in time, and our initial velocity was 0.287 seconds. And essentially you put those initial conditions into the GlowScript app, so we put in the initial velocity as well as the change in time, as well as updating both of the principles. And here is the data on top of each other. As we can see that the computational model was slightly higher, but of course this does factor in some possible friction or human error. And these are some of the things I included. So friction, of course, was the table as possible, as well as human error. When we were making the markers in the tracker app, there could have been a slight discrepancy in the center of mass. And for what if the axes were flipped? Of course, there'd be opposite signs. The slope would be negative. Position versus time would still be constant, and there would be a net force at 0. And are we able to tell how many forces are being added together to give a net force of 0? We would not be able to, but this does not mean that there is no forces interacting. And overall, Newton's second law is supported, and the actual and expected results were very similar, and we can assume that there was a constant velocity. Thank you.